Now in this video lecture we will go through a small mathematical derivation wherein we will find the density of a cubic crystal system from its edge, right? If we know the edge length of a cubic crystal system, how to calculate the density, right, from the length or edge length of the cubic crystal system. Now edge length of the cubic crystal system can be found using an experimental technique, say a diffraction technique. Using diffraction technique, we can find the edge length of the cubic crystal system, and if we know what type of structure is it, so that we know how many particles are there in the unit cell of that cubic crystal system, we can find the density of the cubic crystal system. Now in this mathematical derivation or this quantitative understanding of this, we would be using simple concepts and formula that we have done in previous classes. First is we would be using the concept of mole, right? We know that atomic mass is nothing but the mass of Avogadro's number of particles, right? And the second thing is we will be using the formula of density, which is mass per unit volume, right? So here we are trying to calculate the density of a cubic crystal system, right? Cubic crystal system, and if we know the type of structure that this cubic crystal has, we would be able to find the density, because the type of cubic crystal system, knowing the type of cubic crystal system, we will know how many particles are there in the cubic crystal system, right? Now let's consider the simple cubic crystal system. The structure of cubic crystal system would be simple cubic crystal system or primitive, wherein the particles would be present only at the corners of the unit cell, right? Now let's consider this as the unit cell or the cubic crystal system, right, wherein the particles are present at the corners of the unit cell. Right. Now let's say using diffraction technique, we found that the edge length of this crystal system, cubic crystal system, is A, right? Its edge length is equals to APM, right? So if you know the edge, right, of this cube, then you can find its volume, right? And since we are trying to find the density, we know that density is equals to mass of this unit cell divided by volume of the unit cell. Volume of the unit cell. Now volume of the unit cell can be calculated from here, because volume is equals to side cube, right? It would be APM cube, right? So this would be, we need to convert this into centimeters, right? This would be A into 10 to the power of minus 10 centimeter, A into 10 to the power of minus 3 centimeter whole cube. This would be A into 10 to the power of minus 10. This would be A cube into 10 to the power of minus 30 centimeter cube. This is the volume, right? Now the other thing that we need to calculate is the mass of the unit cell. If this is the unit cell, then the mass of this unit cell would be equal to the mass of the one particle into the number of particles, right? Number of particles, let's say represented by Z into mass of one particle. Now the mass of one particle, will use the mole concept, mass of one particle represented by small m. So this would be, m would be equal to Z, the number of particles, into m, right? Mass of one particle. Now mass of unit cell, right? This is the mass of the unit cell, and this is the mass of one particle, right? So mass of one particle, we know that the one small atom or the molecule it's very small that we cannot calculate its mass. So what we do is we consider the mass of Avogadro's number of particles, right? So atomic mass, the one that this unit cell is an element, right? So whatever element is this, the atomic mass of this element would be equal to the Avogadro's number of the atomic mass, or the atomic mass of this element, would be equal to the mass of Avogadro's number of particles, right? So atomic mass of this, right, atomic mass would be equal to mass of one particle, right? Let's represent it with small m into ZA. I'm sorry, its Avogadro's number is represented by N0 or Na. We can represent it with Na, right? So this will give you the atomic mass, right? So mass of each atom, this is the mass of each atom, this is the mass of one atom, and this is multiplied by the Avogadro's number of particles, right, or the atoms. Now the atomic mass represented by capital M is equals to small m into Na, right? Therefore mass of one particle is equals to atomic mass upon Na, right? Now the mass of the unit cell is equals to Z into M, right? Let's say this is mu, mass of the unit cell. So mass of unit cell, which we need to, this is the quantity that we are trying to find, is equals to Z into M upon Na. This is the expression for the mass of the particle, where Z is the number of particles, right? M is the mass of one particle, right? Mass of one atom, and Na is the Avogadro's number, right? This is your Avogadro's number. So the mass of one particle is M upon Na, right? We have put this value here. This is your capital M upon Na. Now we will put these values here in this formula. Density would be equal to Zm divided by Na upon A cube from there into 10 to the power of minus 30. This is a volume. This is the volume, right? This is the expression for the density of the cubic crystal, right, in terms of its edge, right? This is the expression for the density of the cubic crystal in terms from its edge, right? If you know this edge, right, we have calculated the edge using some experimental techniques like diffraction, right? Using diffraction technique, we find this value of A3. This Na is Avogadro's number, which is constant, right? Z is the number of particles, right, in the unit cell. Once you know the structure of the cubic crystal system, you know the number of particles Z, right? And then M is your atomic mass, right? Whichever element is this, right? You know the atomic mass of that element. So atomic mass is known, this is known, Z is known, right? A is known. You can find the density of the cubic crystal system, right? I'll just quickly again revise this. Calculation of the density of cubic crystal system from its edge. That is, if you know the edge or the side of the cubic crystal system, right, then how to calculate the density of this? We know the formula of density is mass per unit volume. Mass of the unit cell upon volume of the unit cell. Since we know the edge, right, this, we know that the volume of cube is your side cube. So we have taken this in pm. To convert it into cm centimeter, we will multiply it with 10 to the power of minus 10. So a into 10 to the power of minus 10 cube, this is what you will get as, this is what you get as the volume of this cube. Now we have the volume. The second thing we need to know is here is the mass of the unit cell. Mass of the unit cell would be since unit cell consists of the number of particles, if this is the simple cubic structure we have, then the mass would be equal to the number of particles into the mass of one particle. This is simple. So the mass of one particle would be this atomic mass upon divided by the Avogadro's number, because we know that atomic mass is the mass of Avogadro's number of particles, right? So this is mass of one particle multiplied by Na will give you atomic mass. So m, mass of one particle in terms of atomic mass and Avogadro's number is this, right? So this is the mass of one particle. Now we have z particles, right? We have z particles. So we will multiply z with m upon Na, the mass of one particle. We get the mass of the unit cell, right? Mass of the unit cell is number of particles in unit cell into mass of one particle. Mass of one particle is calculated from here. We put the value of mass of one particle, right, which is this. You get the mass of unit cell. So you put this value here and this value here, you get the density of the cubic crystal system. And z is the number of particles, m is this value, right, atomic mass, and Na is Avogadro's number. A you know, so density can be calculated, right? I hope this is clear too. Thanks.